Hi guys, I got a request to look at the first question on 8.06 today, and I decided to create a video because this is going to be a very important concept that you need to make sure you understand for several units to come. All right, so you're given this graph and you're asked to write an equation. And so what I want to do is remind you of what you learned in the last unit about slope and writing equations by connecting what you know with slope. First of all, they talked about the fact that slope is the change of the y's, also known as the vertical change, over the change of the x's, which we say is the horizontal change. Now, mathematically, we have a formula for this, and it's called slope formula. And I'm going to show you what it typically looks like. It's a little different than what they've been showing you so far, but I'm positive they're going to transition to this one. But change of y's is simply, because let's think about how you would find this on the graph. You'd say, well, if I start at this point and I go up to this point, if I can get it to go, there it goes, because that's where your second point is. We want to know what is that vertical change. Well, you'd come over here and you'd see a 28, and then you'd come down here and you'd see a 14, and you'd say, well, 28 take away 14, that length has to be 14. Okay, so what did I just do? I actually started with the second y, known as y sub 2. That's all that is referring to when you see that drop down number. It's saying the second y. And I subtracted the first y to get my 14. Now, to do my horizontal change, I would focus on my x's. So if I'm at 8 and I'm go to 16, what's the math I would actually do is 16 take away that 8 to know that's a length of 8. So we'd say the horizontal change is 8, but what did we end up doing? The second x take away the first x. That formula right there is known as slope formula. Now they've been changing it a little bit. They've been showing it this way. Y minus that first point, so the first y, and x minus that first x. So just y over x they've been referring to as the second one, and then you subtract that first one. Okay? But they're really the same thing. So don't worry about the fact that the formulas look a little bit different. So what they're wanting you to do for writing an equation is remember how they did that. They had you go y minus that first y, and x minus that first x is how you find slope, and say, well, that's going to be equal to what we get for slope. So what did we get for slope? We got a 14 on top, and we got an 8 on bottom. Okay, now you can reduce that to 7 over 4, but I'm going to leave it as 14 over 8 right now because I really want to enforce an important concept that you're getting ready to look at. Okay, so here's one equation that works, but it is not the best equation. We can do better. So I'm going to get a new slide. I'm going to copy what we've got so far. Y minus y sub 1 over x minus x sub 1 we know is equal to 14 over 8. Okay, how can I make it better? Well, I could get rid of that fraction, all this junk of the y minus y sub 1, x minus x sub 1. We know what y sub 1 and x sub 1 is. That first point, remember, the x was at 8 and the y was at 14. Whoa, I've already got those numbers. That's not a coincidence on this. Okay, but let's carry on. So I'm going to get rid of these sub 1 numbers because that just jumbles up this equation. I'm just going to plug in what I know y sub 1 and x sub 1 is. So it's going to become y minus, what was that y, 14 over x minus, the x was 8, we know is equal to 14 over 8. That's kind of interesting, isn't it? Okay, let's go ahead and carry on. All right, so that's an equation that works, but I can still make it better. Let me show you how I'm going to make it better. So now we got y minus 14 over x minus 8 is equal to 14 over 8. Okay, so how are we going to make this better? Let's get rid of that denominator. I'm going to multiply both sides by the quantity x minus 8. And when I do this, that quantity and that quantity will cancel each other, and we get y minus 14 equals, all right, I go ahead and distribute. 14 over 8 times x is just 14 over 8 times x. I read it that way. Now 14 over 8 times negative 8 ends up negative 14. Okay? So now that's an equation that works, and that one has a name. That is called point slope. Okay, point slope formula is this. They say go take your y and subtract the y sub 1 and make it equal to the slope times the quantity, the x minus the x sub 1. So that looks pretty familiar, doesn't it? Okay, but that's an equation that works, and we know that it's equal, but I can still make it better. I'll show you how I'm going to make it better. So where were we? We had y minus 14 is equal to that slope of 14 over 8 times the x, and then what did we have? Minus 14. Okay, so how can I make it better? Well, I can get the y alone. There's a very good reason for wanting to isolate the y variable, and I'm going to show that to you. So I'm going to isolate it by getting rid of that negative 14 with a positive 14. Those cancel, and this gives me y is equal to 14 over 8 times the x, and those cancel. So I could put down plus 0, but for equation's sake, we typically leave it like that. Okay, that has a name. It's got a couple names, actually. In the form I have it, it's typically called direct variation. And what does it mean? It's meaning. It means the y's are always equal to the x multiplied by 14 over 8, but we write that as y equals 14 over 8x. It means if I want to know a y variable, a y value, and I already know the x, say the x is 24. Okay, let's just guess. The x is 24. I wonder what the y is. See, now this equation helps me to figure that out. Y is going to be equal to whatever 14 over 8 times 24 is. So I could find that. I can cross cancel and now realize, okay, 14 times 3 is 42. The y value would be 42 when x is 24. So that's why that is actually the best equation to use, to simplify it down, because it's really easy to use. But let's go ahead and talk about the fact that our slope, I'm going to use m for slope, so the slope was 14 over 8, and that first point was for also an 8 for the x and a 14 for the y, and if I take that point and write it as y over x, what do we get? 14 over 8. We get the same thing as our slope. So I want to go back to what we were just looking at. We had y equals 14 over 8x. Remember, whenever I was simplifying this, and I went up, we went ahead and distributed. And what did I end up getting? Over here I got the 14x, and then I got minus 14, and then I added 14 in order to isolate the y. And what did that turn into? A plus 0. Okay, that's important. Now that I have it written like this with that plus 0, that's called slope-intercept form. And slope-intercept form is this. The y is always equal to the slope, m stands for slope, times your x added to, we put a B. B stands for the y-intercept. So M was slope and B was y-intercept. And y-intercept means the point that the graph touches the y-axis. And if you remember, it touched at 0, 0, the origin. So when it touches at the origin, that is always going to end up a 0 because you just plug in the y value there. And then you have the slope. But the biggest thing that I want you to know, if the first point is written as y over x is the same as your slope, that happens when that graph goes through the origin. That will always happen, okay? And so if you notice that is happening, writing an equation is fast and easy. You just use what we call direct variation, which is y equals the slope times the x, and you just plug in your slope right here. You just write y equals 14 over 8x. You find your slope, you plug it in, and boom, you've got your equation. All right, hopefully this helps a little bit and helps to tie in some things that you've seen to what you're getting ready to see. Thank you for asking about this question, and good luck.